Hello everyone and welcome to another AP Computer Science video. This video is going to focus on retrieving user input from the keyboard in Java. So there are a lot of ways to accept input from users. This could be if we're in a GUI, meaning a graphical user interface, clicking buttons, clicking items, selecting things, typing information. If we're using the console like we're going to be using, it's mostly typing from the keyboard. We can read files that users create and pass to us. They can pass to us a variety of ways. We can connect to the internet and read data from the internet. We can connect to a database of information. So Java has many different ways to read information from users and from other computers. Users are not necessarily human beings, or the input that we get is not always from human beings. But our first programs will mostly be us typing into a keyboard, someone typing into the keyboard, perhaps me for testing of your programs. And we'll deal with that as we start. And we'll see more complex ways to do this as we move along. I want to mention the AP exam doesn't really test on any form of user input, primarily because they believe that because there are a variety of ways to do it, and some people think old ways are good, some people think some new approaches are better. There's a lot of debate about what's the best strategy and if there's one way that should be taught to an exam, and they basically said we don't want to do that. And so they leave it up to the teachers to teach how they want. We need to know how to get user input to make interesting programs, but the AP exam won't really test for that kind of stuff. They'll make the assumption, oh, the user typed in or gave you this information, and then you can do what you will with it. How it happens is not important to them. But for us, it is important. So we're going to use one strategy that I think is pretty easy to get into and is effective and gives us a good amount of control without too much programming or struggle going through it. So we're going to make a new file to make that happen. So I'm going to right click on my basics package and we're going to make a new Java class. I'm going to call this user input. And so there's my class user input. I'm going to go ahead and make my main using my shortcut. And there it is. And so what I'm going to say is that we are not necessarily going to do the best approach to user input or the safest. Instead, we're going to to make things easier for us, we're not particularly concerned with handling all the real-world scenarios that might occur when things go on with user input. Right? They could type in the wrong information, they can connect in the wrong way, there could be interruptions, things like that. Files could be missing. And so what we're going to do is we're going to work with our connection as best we can, and we'll deal with any issues that will come along. And we'll learn how to defend against common mistakes as they happen. But initially, it'll be pretty straightforward, and we'll be reasonably safe in assuming that input comes in the way we expect it to, and we'll deal with only very simple issues. So how is this going to work? Essentially, we need a special object or functionality to help us connect to the keyboard of the user, and we're going to do this through the console that we see. So we've been printing stuff out, and in NetBeans it shows up in this little bottom console, and so that's essentially where we're also going to be allowed to type. And so what we do is we'll make a connection to that typing. We already have a connection to display content outward. We use system.out.println and system.out.print. The reverse direction takes a little bit more work, but it's still relatively easy to do, and once we have that connection, we can tell the program to wait for user input, or once stuff is typed in, absorb it and do what we like with that information. So we're going to go ahead and set up our first thing. So we're going to go ahead and write to receive keyboard input from a user. We need a connection to the console. And so how we're going to do this, we use a scanner object. So we're going to see something called a scanner, and this is kind of like a string. It is a non-primitive data type. It is an object, and again, we use the word object, and that is a pretty vague term, but we essentially mean a thing that does something. It has information and has behaviors. Right? Integers don't have that. Integers are just data. Doubles are just data. Scanners are objects, they're complex, they do things, and they keep track of information at the same time. And so a scanner object is way more complicated than a string, as complicated as strings are, and has a different goal in mind. Its goal is not to keep track of individual characters together, but instead to connect to some user device and then absorb information and potentially do something with it. So we use a scanner object to connect to the console. And so how are we going to do this? First, we have to declare a variable. And because scanner is a non-primitive type, it is a class type, we can declare it as a variable. So let's go ahead and do that. I'm going to do it in 2 lines. I'm not going to initialize like we've been doing in our last videos to be shorthanded. I'm going to do it on purpose in 2 different lines just so we can see the 2 steps. The first is the declaration. So scanner is our type. And again, it may seem odd, but types are essentially either primitive values or primitive types, or class types. Class types like string, scanner, and again, what makes them class types, makes them more complex, at least visually, is they start with capital letters. Primitive types do not. So, and then we have to give it a name. I often call mine, since this one is connecting to the keyboard, I'm going to call it KB. The name is not important, but we have to decide what we think is an appropriate name. So input is not a bad name, KB, or console, or something like that. All of those are reasonable, or terminal, all those are reasonable choices. The name is not that important. There's an error already to begin with because by default, even though the Java language has many, many, many classes, to save space, we don't necessarily connect to all the functionality available to us immediately. We instead use what are called imports to do that. And an import basically says, can you find a particular package and make its code available to us? So technically speaking, since we've made a package called basics, we could potentially set up another program that could use our basics package. Now our package doesn't have any really genuinely good stuff to use, but if we wanted to, we could have access to these things from somewhere else. And so the package that we want for the scanner is a particular one. I'm going to write it out this first time, but in the future, while you need to be aware of the import command and how it works on the AP exam, you're not required to write it yourself. So we'll use the shortcut in the IDE to save us the work of having to hunt them down and know what they are. But I do know a few off the top of my head, and so we'll do this one, and just so you can see how it's written. So we have the package command is one of the few ones that we said was outside of our class declaration and outside of the main. Imports are also lines that do not happen inside of a class. They're kind of a marking point saying, hey, I need you to find me some code that I'm going to have access to. And so the command is going to be import, and notice how it turns orange because it's a keyword. And then we have to give it the name of the package and then end it with the name of the file or the object type that we want. So the package we're going to use is java.util.scanner. And so I have to give it a moment. My computer seems to be struggling with finding the scanner, but it is there as a... okay, I don't know why you chose to do that, but let's go ahead and put that. And so there it is. Java.util.scanner. I don't know why I chose to kind of stick the other one in there. And you see that it's correct, there's no error. And immediately, it now recognizes scanner as a proper data type. It says, okay, I know what a scanner is, and I know what its behaviors are and how to use it. And so now this is a data type. So you'll see that string, we never had to do this because strings are so fundamental that they said we'll include them by default and you have access to them immediately. Scanners, as useful as they can be, are relatively modern in Java, and so there are many different classes that they've slowly said, okay, we'll put them away, and if they want them, they have to import them. The program has to import it, him or herself, and that's perfectly fine. So I've declared my variable KB. It is of type scanner. And so now we need to initialize it, and the way we initialize objects, if we created them or if someone else did, and so the scanner was not created by us, it was created by someone else, we use what's called the constructor. It builds the object in RAM. It says, hey, find the space, we need to set this thing up, and then you can use it. So it's very much how we initialize, but it's more than just the data, it's actually the setting up of all the content and behaviors. So we're going to say KB equals, and so the assignment is just like if it were a primitive, but then we have to use a keyword, new, which we saw when we did the string constructor, and that was also a very similar idea. And this constructor for the scanner, we use the same name as the class and the type, so it is scanner. And then what we need to do is give it parentheses so it has input, and then some constructors have inputs. We saw the string constructor said that it needed the thing it was going to copy. This scanner, what it needs is the thing that it's going to connect to and read data from. And in our case, what we're going to read our data from is the keyboard or console. And in Java, the default connection to the console, wherever it happens to be, whatever program it happens to be, is in a piece of information called system.in. So we've seen system.out, and we saw that it had the println command and the print command. There's also one called system.in. And so there it is. So we've made our connection. .in is actually what's called an input stream, and basically it means a connection for data coming into the program. And system.out was an output stream, which is how you can send data out to whoever it's going. And so they're kind of like partners. And if we want data to go out, we use system.out. And then if we want data to come in, we use system.in. And so now the connection has been made. It says not only does this scanner exist in RAM, but it has a link to the console so that we can potentially ask it for information that may or may not have been typed by a user. So there's our constructor. So let's go ahead and say we construct a new scanner object and link to the input stream system.in. And so there's our connection. And now basically we have the ability, and we're just going to use methods dot notation. There are many methods. String had its own set of methods, and we only went through a few of them, even though there were many more. Here there's a good number of methods that a scanner has. These are behaviors associated with the scanner, and we'll go through several of them. But again, there are so many that we'll kind of come back later on when we do more input. But for now, we only need to learn maybe 3 or 4 different commands or methods. And so what I'll say is, before we ever use these methods, we have to make sure that the user knows that they're being asked for information. If we had our program just sit and say, okay, I need data, but we never gave the user a visual clue, they might not know to type in something. They might see the cursor blinking and go, okay, why is the program paused? What's happening? And then we actually think, well, as a programmer, why isn't the user typing something in? And so to stop that, typically the first thing we do is we send a message. Oh, please enter your name. Please enter the number of chickens in the room, or whatever the data we're asking for. We make it clear to the user that we want it. So let's go ahead and make a command. We'll print out a message that says enter your name. So we're going to do a typical print. We're going to say system.out.println. And then we're going to go ahead and say enter your name. And I'll put a colon in space, and this is just a matter of style. The space is not necessary, but I think it makes it look a little bit not so crammed. I think it's a better choice. And I'm also going to choose not to use ln, because when the user types, I would like to see their message typed next to mine, not underneath it. If the ln is there, then that means the line break will be inserted, that enter key, and then when they type, it'll be below our message. And typically when they say enter your, if you ever think of like a movie or where you've seen like a hacker working on a thing, there's usually some little marking point where they're typing, and then it shows up next to it. So I want the text that they're going to write to end up right next to the enter your name colon. So I'm going to get rid of the ln in my command. The print command does the same thing, but there is no extra line break or new line character. So that is just the message. If we do that, the program will end and it's kind of over, and that's not really good enough. And so now the act of retrieving data, we're going to use one method to make this happen. The first method we're going to use. And this method returns information to us. And if we don't do something with it, it's gone. So let's remember the data we're going to retrieve and put it somewhere. And it's going to be a string, so let's make a string variable. So here we go. We're going to say string user name. I should maybe do capital N. Oops, come on. Name is equal to, and here's the command. We're going to do dot notation. So what is the object or the variable that is calling the command? When it was a string, it was our string variable. Here it is the scanner object. So we're going to say kb dot, and again, I'm going to just kind of hide that. NetBeans is being very helpful by trying to show us what's available, but I don't want us to kind of be bogged down by all the extra details. And so our first command we're going to learn is called next line. And notice, just like with strings, the standard for the Java language and stuff that was created by the developers of Java is camel case. Line is capital L. It is a method that accepts no input. But just like some of the string methods, we are required to put the parentheses because it is a method or function and therefore needs a parameter list even if it is empty. And so that's what those parentheses are. And so what happens is if the user has typed something into the console, it sits in, well, whether if they haven't typed something in, let's say, it kind of pauses the program and sits and waits. And then eventually when the user types something in and they hit the enter key, that's when this line will run and it'll pull in every character that was written up to, but not including that enter key. The enter key is kind of lost. It's thrown away because that was kind of the marking point of, hey, I'm done typing. And so next line is good because what it does allow us to do is take up as many characters, including spaces, as we want, as one giant sentence or line. It does not consider white space, meaning tabs and spaces, as separate. It actually includes them as part of what they wrote, but the new line character is the kind of marking, and we'll use the word delimiter, and I'm going to write it out in a moment, but the delimiter for next line is the enter key or new line character. So we'll see that in a moment. And then I'm going to maybe, let's say, mirror back what they said. Let's say hello, whatever your name is. So let's go ahead and print out a message. So system.out.println. And now I can say hello. And then I'm going to use string concatenation, which, remember, the plus symbol connects two strings or a string with something else. And I want to attach my message, hello, comma, space, with whatever their name is. So hello, user name. And then I'm going to maybe attach an exclamation point because we're excited to see the user. So we're going to go ahead and do that. So let's go ahead and try running this program and see what happens. It'll be a little bit different from the programs we've done before. We'll see it start, and then we won't see that green build successful until the very end. So notice, it doesn't say build successful. The program is still running. You can actually even see at the bottom right of my screen, it says APCS notes HT run single, running. The program is paused because the way the console works is if nothing has been typed in, it just sits and waits. That next line, it kind of freezes up the program and says, okay, I'm going to wait, I'm going to wait, I'm going to wait. And then I can type something in. So I can type my name, and I'm going to say Joseph. And so I haven't hit enter yet, so it's still waiting. But as soon as I hit the enter key, the next line will run. So this thing will finish, and it'll store whatever I wrote, which in my case will be the word Joseph. And then this line can run immediately and then display Joseph. So I'm going to hit enter. And there it is. Hello, Joseph. So the next line command is kind of what's called a blocking command. It stalls our program and waits if there is not enough information inside the command. So let's write some notes to this point. So let's say scanner method, and we'll say next line. So waits for the user to enter information, and only continues the program when the delimiter is is entered. The default delimiter for next line is the new line character \n, or we can call it the enter key, right? It's the new line character. And so there it is. And so to prove my point that it will ignore white space and do, and the reason I bring that up is because we'll see that another method is a little bit more aggressive in how it takes apart your input. This one says, okay, I'll just sit here and wait until you hit the enter key only. The enter key is the only factor in allowing it to continue. So I'm gonna run it again, and I'm gonna go ahead and put more than one word. I'm gonna say Joseph Rivera, and then I'm gonna hit enter. And notice it says hello, Joseph Rivera. And if I run it one more time, and I enter other stuff, I can just type in things, and I'm gonna put a bunch of stuff. It's just gonna keep going. I can sit here and I can walk away from my computer and come back 10 minutes later, and it will still be waiting. And then as soon as I hit enter, that's the giant string. This entire message, every character except the new line character, was inserted into the string that we wrote. And that's okay if we want multiple sentences. If we want multiple words, next line is a good choice. Now that said, that we might sometimes want to take in one word at a time, and just in case they type more than one thing, we still want to take only one thing, and so we have another command to do that. So we'll go ahead and try that out. So let's say we're going to do another note. We're going to say scanner method, and we'll call this one next. And so next also returns a single string, but it only reads up to the first white space delimiter. That means if you type in a space or a tab or an enter key, then it stops and reads up the first chunk up to the first white space. So the enter key still is what moves us forward in our program, but what it actually reads is only the thing up to the first available white space, which is either spaces or tabs, basically. And so let's try this. So let's say string word. And we'll start off and we'll say, well, let's actually go ahead and do this. Before we continue, let's go ahead and put a message, because we're going to ask them to type something else in. We're going to say, I'm going to use the shortcut, system.out, there it is, enter at least 2 words. I want it to be 2 words on purpose, even though I'm only going to read one at a time, because I want to show how this, we can control whether we take all the information at once or not. And so we're going to say enter at least 2 words, and now what I'll do is I'll say word 1 is equal to KB, which is our scanner, dot next. And so let's go ahead and put that. We'll say retrieves user user input and returns it as a string, but only reads up to the first white space delimiter found. So we'll say spaces, tabs, new lines. So here we go. I'm going to run it, and then let's go ahead and put a message and say your first word was, and then we'll attach the word that they gave us, which is word 1. So here we go. I'm going to run it. It's going to ask for my name, which with the next line. So I'll just go, and I can put more than 1 word if I want, and it'll take it all. I'll put 1. Enter at least 2 words. And notice what happened. The cursor's down here because I put print ln instead of a print, but that's okay. I'm going to type 2 words, abba zabba. And if I hit enter, what we're going to see is next only takes the first one. And there it is. And actually, since the program ends right there, we kind of lost that second word. Zabba was never used. It was never kind of read into the program. And so that's a decision we have to make. If we use next and next line, it's because we are guessing or assuming what kind of information is going to be given to us. And this is a kind of a useful thing, but it does require us to be aware of what kind of information may or may not be entered. And so now what I'm going to do is I'm going to take a second word, word 2 equals kb.next, so the same thing. And then I'm going to print out system.out.println. I'm going to use print this time. I'm going to fix them both to be prints. Oh, sorry, this one will be a println, and I'll say your. Oh, I'm sorry. This stays in ln. It's the message up at the top that should be a print. So println your second word, and we'll go ahead and attach word 2. And let's go ahead and try running this and see what happens. And I'm going to do it 2 different ways. The first one, I'm going to do what I did the first time. So it's going to ask me for at least a sentence or whatever it may be with next line. There it is. And now it says enter 2 words. I'm going to put abba zabba. And we're going to see that we're going to get both of these immediately. We're going to see first word abba, second word zabba. So here we go. I'm going to hit enter. First word abba, second word zabba. And so it splits it up into individual, what we'll call tokens or pieces from the original single entity that was entered. And now I'm going to run it again, and we'll do something slightly different. So here we go. There's the next line, and now I'm going to do this. So notice I hit ABBA and hit enter, And so the next caught that first one because the enter was a white space character. So it absorbed the word ABBA, and then it printed the message. And then because this thing was expecting, since I was expecting a second input, a second word, it was never put in. So now the program has to stall and sit and wait. So if we tell the user enter two things, and we read them one at a time with the next command, but they don't enter two things, the program has to kind of stall and stop and say, uh-oh, I need more data, and it'll sit and wait. And it'll sit here as long as it takes for me to write in a second thing. And now if I type in something, and notice the real disadvantage of this is that if they don't type in everything that you want at once, there's no other message to say, oh, enter your second thing. It said right at the beginning, enter two words, and now it's kind of waiting for that second word. And so if I put Zaba, then it's going to finish up. But if I put multiple words, so Abba Zaba, hello world, we're not going to see hello world. They're also going to be lost. It's only going to take in one token or one piece at a time based on white space by default. We will in the future be able to change the delimiter to something more exotic, so we could maybe cut it up by dashes or commas or any symbol really we want. The default behavior is white space, mainly because most languages use space to separate words. And so if I go ahead and just I'm going to go ahead and only type in Zaba and enter it, and then the program is finally ended. Notice how now the times aren't 0 anymore because it includes the time it takes for me to enter. So I waited almost a whole minute to finish the program, and over a minute to finish the program. And so next is a great tool if you're going to expect single words, whether they type in more or not. So if you say enter one word and they type in 20, you're going to only take the first one. And if that's your choice, that's okay. But if they decide that if you want them to enter more words, it's not going to allow them to enter more. It's going to take whatever's still in it. You have to imagine kind of like a pipe with stuff being inserted. Every time they type in a word, it's stuck inside this pipe. When you call next, you retrieve one chunk of the information from the pipe. And if you tell them enter more, and they type in more, that's not going to be caught immediately because there's still stuff in the pipe from the last time. And so it won't make them wait until all the information is taken. And the next line is kind of like, you know what, empty the pipe all at once into one big thing. And so we have to kind of decide ahead of time how we're going to approach taking input. And so I'm going to continue. And so along with next, there are basically two other versions that do the same thing. They also take stuff by white space, but they take an extra step and they convert the data that we read from a string into whatever type we ask it. So I'm going to do this kind of as one thing, and we'll say scanner methods, and we'll say next int and next double. And there are a few more, but I'm going to stick with just these two. And I think this is more than enough for us to get going in our project and for a lot of the input we're going to start with initially. And so these do the same thing as next, but convert, well, I'll say, but attempt to convert the data into the type specified by the method. So next int will attempt to convert whatever was read as into an int, and next double tries to convert it into a double. And I say attempt because if you put in data that cannot be converted, it will cause the program to crash. We talked about earlier exceptions, errors that may happen while the program is running. We saw one example of an exception, a arithmetic exception divide by 0. We're going to see some new ones here. Particularly, I think one called input mismatch exception if we put in data that cannot be converted. For example, I ask for an int and they type in the word banana. It will not work. It will cause a problem, and we'll see that. So here we go. So we'll go ahead and do something like enter a number and our colon. And then now, let's go ahead, and now we can do int num is equal to kb.nextInt. And this version, and again, there's another version, but we're not going to look at that one. It's not really helpful to us. It says you write something in, and I will try to absorb it and convert it into an integer, right? And so let's go ahead, and then I'm going to go ahead and say your number plus 5 is, and what we'll do is we'll concatenate. We'll say num plus 5. And I want to point out I'm doing the addition in parentheses very much intentionally, because we know that the addition symbols or the plus symbols are left associative. So if I read it from left to right without the parentheses, we would concatenate their number to the sentence, and then we'd concatenate that string to the number 5. We wouldn't actually sum the two numbers. So I'm saying do the mathematical addition before you do the string concatenation. This is very much on purpose. Otherwise, I would get the wrong answer. So for example, if they typed in 10, if I didn't have parentheses, we would see 10. We would see 105, 1005. Here, if they typed in 10, we expect to see 15, which is different. So here we go. Right, I put my name. This is the next line. There's the 2 words, Abba Zaba, and then here it is. Enter a number, 10, and there it is. Your number plus 5 is 15. It did the same thing as next. It took it white space at a time, and I'm going to run it one more time just to kind of prove this. Oops, let's do this over here. So Joseph, Abba Zaba. I'm going to go and type 10, 15, and 20. And I still only see the 15 because these are ignored because we never called next int on them. And so now what I'll do is I'll say something like enter a decimal number. And I'll put that, and I'll get rid of the ln. I always forget to do that. And we'll say double des is equal to kb.next double. Notice it is camel case, still no input, so we leave empty parentheses. And now let's try and go ahead and say something like system.out your number, your decimal number divided by 2 is, and we'll attach, and we'll do the same thing. We'll put math first, des divided by 2, and because des was converted to a double, it will not truncate. We will get a fractional answer, which is what we want, and it'll display as 5.0 if it was 10, or some fractional number if it's a fractional number. So let's try that. Here we go. So here it is. There's the name. There are the 2 words, and then enter a number. There's the 10. Enter a decimal number. Let's do 7. And there it is, 3.5, because 7 was interpreted. And so now 7 was a whole number, but we know that integers can be converted to doubles without any problems. And so the last thing I'm going to do is I want to show you one quick thing that proves that this thing only waits if it needs to, but if there's data in the pipe that is the console, it won't wait. And it won't wait for more. And then I'll show you the exceptions that may occur if we screw up on our input. And that should be enough for us to get our input going. So here we go. I'm going to run it one more time. And this time, so there's the name, there's the 2 words, and here we go. I know, because I wrote the program, that it's going to ask me for a number and then ask me for a second number. I'm going to put them in both at the same time. So 10 and 7.5. Right? 7.5 we know will divide into 2, which will be 3.75. But now, the argument I'm going to make is, you might think that it asks for the integer, takes in the 10, and then asks for the decimal, and then waits for new input. So you might, and again, I kind of said that it sometimes throws out what's left over, but that's only if the program ends. Since the 7 is still in that pipe in the console, when we call next double, if it doesn't cause a problem, it'll immediately absorb the 7.5. It's still in there. And so it won't even ask me to type in something because officially I've given it enough to handle both calls to these methods. So here we go. I'm going to go ahead and enter. And notice how it didn't ask me to enter the decimal number. In fact, it ends up kind of ruining the look of our program because the 7.5 after this point was still in the stream of the console, in that pipe. And so it took the 10, did the math, and then immediately took the 7.5 even though I didn't type it in the second time around. It was still there to be accessed. And then it said, okay, here you go, 3.75. And the reason that we don't see this on a new line is because the message should have been typed into and it was a print. But because the data was already there in the pipe that is the console, it didn't need to ask me again. It just ripped it out as a double, converted it, and then allowed me to do the math. So we have to be kind of very clear about what we're asking the user for. And I'll say that there are ways to handle this more gracefully. When it comes to our project, our work, I will usually tell you you may assume that the user will type in exactly what is asked of them. Or I might warn you, the user may enter letters when numbers are expected, and you'll have to handle that as you see fit. But the idea is that, generally speaking, when we start, I won't try to put in more than you ask me to. So it's fair, and we're not prepared yet to learn how to handle some of those problems. But I do want to show you the problem, so I'm going to finish up by breaking our program on purpose. Okay, so I'll point out typing in numbers when it asks for next line is not a problem because numbers are characters, so that's not an issue. Hello, there it is. If I put 2 words, I can put, symbols, and there's no problem because those are also strings. But now here, enter a number, A. Bam, it crashes our program. It says input mismatch exception. Right? It says, look, on line 44, I tried to read an integer, but what was in the console, in that pipe, was something that could not be converted, unfortunately. And this is funny because we might agree that the letter A, we talked about this last time, the letter A is technically basically a number, right? Characters are numbers behind the scenes. But next int is not going to do that kind of assumption. It's not going to think like that. And so it does not try, it fails to convert and crashes. Similarly, let's do another one. I'm going to do it again. Enter my name. There it is. There it is. And here we go. I'm going to put 10.5. 10.5 is a number. However, when the next int command tries to convert to an int, it will not work. Same problem. Input mismatch exception. Right? And so it says, look, you tried to give me a double, but I cannot convert it to an int safely, so it crashes. It's not going to handle things gracefully. Let's do one more. Oops. So let's type in a thing. We'll type in a thing. And so enter a number. And so I'm going to type in, for the decimal, a number, 10. There it is. For the decimal number, I'll point out the only situation where you're allowed to put letters is if we're writing in scientific notation. And so this will work if we do it correctly. So if I try 1.5 e to the -2, that's what, 0.015, and if we divide that by 2, actually let's make this a 4, so it's a little bit easier. So I think we should get 007 as an answer. And it did work, because it's able to read scientific notation as a double. If I had put 0.014, it would have also worked. But the idea is that that's kind of the only time you can get away with sticking letters into the next double. If I tried that with next int, it would fail, because that is not a way to do that. Actually, we can try it, because that's something I'm curious about. So here we go. So I'm going to put a number. I'm going to put 10E5. And there it is, right? When you use E, even though this is essentially, we can agree that this is a giant integer value, right? Because there's no decimal point. E's imply that it is a double, and therefore it will not work with next int. So there's our basics for getting input from the user. And in your project, you'll be able to ask for words, you'll be able to ask for numbers as necessary, and handle that data and do what you like with it. So the video's going to end here, and I'll see you in the next video.